So thanks, Bruno, for the introduction. I'm glad to be here. Actually, this is my first international talk. I've been talking throughout events in Brazil, but this is actually my first in US and first actually internationally. So thanks for this privilege of being here. And today I'm going to talk about a brand new topic, actually, called Java 25. Just got released last month. Before we get started, is there anyone here already using Java 25? Raise your hands. No? Anyone considering migrating to Java 25? So? Okay, go. I hope after this talk, so you guys are motivated to migrate to Java 25, because actually this is a really interesting release, like in many years, I would say since Java 20 first. I think I see some guys are new. Some of them are already working for quite a time, and probably let me just forget to. And probably have heard this: Java is dead. Haven't you? A lot of blog posts, a lot of stuff on the internet saying Java is dead, and actually we keep hearing this like all the time. All the time. I just got like 4 events that happened. That most of the people went on Twitter, on LinkedIn, and saying Java is dead. Remember, on Oracle acquired Sun in 2009, and all of the people said Java is dead because Oracle acquired Java, and then it means that no open source anymore and things like that. So Java is dead. Okay, Java is still here. Node was released also in 2009. Also, Java is dead. .NET Core, I think the first open source release from Microsoft, 2014, Java is dead. And the most recent one was Kotlin released, and Google announced that they will start using Kotlin as their primary language on Android, 2016, Java is dead again. But here's the thing, guys. According to Tech Republic research, 90% of Forbes 500 companies, they are using Java. That is not a small number. So it's a huge amount of companies. So the chances of you getting hired for a company who uses Java is quite high. Okay. Another thing is like Java is still in the top 4 of most popular languages according to TIOB index. I don't know. Have you ever heard about TIOB? Yeah. So yeah, they kept measuring languages over time. So I think it starts from early 2001, something like that, and then throughout all those years. And Java is still top 4. It was top 1 like for 8 or 7 years straight. Now it's top 4 because now we got behind Python, C++, and C# just because of the AI hype. Okay. This is one of the posts that Bruno did earlier this year. It was on Java 1. I don't know if you guys know this guy, Paul Baker, software engineer from Netflix. So he went on stage at Java 1 and said that everything we build is built in Java. So Netflix runs on Java, basically. And then Bruno posted this one, and it got like over 1 million views, like a tons of comments, like good and bad comments, of course. Yeah. So what does that mean? Java is still a really strong language. Even though in 2025, so Java is still a thing. Java is still trying to keep up with the most new technologies, AI. So where we have like LangChain4j, we have a lot of things happening into AI world in Java. So you just got a presentation about Spring AI. So Java is still a thing, yeah? So this is one of the things that I say. So that means being dead, so what the heck, isn't it? Yeah. But okay, I think most of you guys came here just to see what's new, yeah, and why we want to migrate from Java 1 version to Java 25. So one of the most important things that we have here is Java 25 is an LTS version. It's a long support term. It's a long-term support version, which means that we'll get support all the way at least 10 years. We see that Java 8 is still supported by Oracle. And Java 8 was an LTS release, and then we have Java 11, and then Java 17, and Java 21st, and now we have Java 25th, which is also an LTS version. So migrating to an LTS version is always a good thing, because you know that it will be supported for a really long time. Okay? It's new. Let's talk about things that is new. Not that much interesting, but it's always good to know. So I separate these ones first. So this is one of the things. Yeah. So starting on Java 25th, so we are not longer supporting x86 processors, 32 bits processors actually. So we are still supporting ARM 32 bits, but not x86 32 bits. So we're no longer supporting AMD or Intel 32 bits processors any longer. This is actually a good news because of the old technology on those processors, it was not allowing Java to evolve, because ARM and the new processors, they have like a lot of technologies that keep up with AI technologies, neural engines, GPU, and things like that. So getting rid of 32 bits or on x86 allows us to progress even further, especially when we talk about vector API. I don't know, have you ever guys heard about a vector API in Java? Yeah, we can talk about a little bit about it later, but actually it's a feature which is in preview, and the idea of this is allow us to do mathematical calculation directly using registers in the processor, just like we're doing AI. So it will allow us to use Java for deep AI things. And this will allow us to move further and then allow to release the vector API sooner. Okay. And here we have like 4 things, not so important, but they're always good to know. So we have Shenandoah garbage collector. They just released now the generational Shenandoah, which means that it has a different way of treating young and older generation objects, and it's great for heap size over 100 gigs. So this is one of the thing. It's not default. So if you want to use it, it has to be enabled. Another thing is like the key derivation function API, which is a new standard for post-quantum protection. We know that quantum computing is getting more and more visible, and then we want to be ahead of time and get protected from hijackers and from crackers that want to break through the secure algorithms that we have nowadays. So this is a good step further on that direction. Another thing that is really interesting, which is the cooperative sampling in GFR. Do you guys use GFR for anything? Yeah. So for those who don't know, GFR it's an observability tool that you can use for monitoring specific things on your JVM. So you're monitoring threads. You can get timing and things and performance things from your JVM. The problem is it needs to run in parallel with your application. So prior Java 25, we had an issue that sometimes, because you enable GFR on your application, it might crash depending on what you were using. So this cooperative sampling allows you to enable GFR without crashing. So you can rest assured that if you enable it, so it uses a cooperative mode, which allows your application and the GFR runs at the same time smoothly without crashing your application, which is really good. And another thing is now that the GFR allows you to trace methods timing, so you know how much time you spent on method calling. We will have CPU probably in the next release, but this one is already final, so you can start tracing methods calls and the time you spent on the calls using GFR, which is something really good. So from that, let's talk about what is serious about Java 25. Java 25 introduces some serious changes that might help you, might help your company, might help you as a developer to go to do things better. So one of them is the AOT, command line ergonomics, and method profiling. So what does that mean? In Java 24, they introduced something that we probably might be familiar with, GraalVM, some native compilation procedures that is ahead of time. Okay, since Java 24, now you can go ahead of time with your classes using the JVM as well. It includes actually 2 steps for you to doing that. You have to train your JVM, so you need to run your application in a training mode, so it understands the most used classes, and then it generates a cache. So it's a 2-step process. And now it's a single step. So we got like up to 45% gain on app startup if you use this training. And you don't actually need to change your application at all. You just need to train your current application, your current jar file, generate the cache, and then rerun using the generated cache, and then you can get this performance boost. And this is really nice, isn't it? So just a quick overview. So we used to have 2 steps for training. Now just 1 step, AOT cache output. So it trains and creates the cache in a 1 single step. And this one, another huge thing, is compact object readers. So we know that we have an overhead when creating objects in Java. It normally used to take about 16 bytes every object, and sometimes they are not even used in total. You know, so actually we were wasting some capacity, some memory capacity on this overhead. So with compact headers, so now we can reduce up to. Oh, I just see that these slides are in Portuguese. Yeah, I'm sorry. Yeah. But the idea is like to reduce to 6 bytes the object reader and reducing 22%, actually reducing 22% the memory usage, and in terms of memory gains, about 12%. Sorry for this slide. So this is not enabled by default, so we have to enable using the VM options, use compact object readers. This is another one that you can run without even changing a single line of code. You just run your JVM, give it this with your already compiled jar file, and you can start running it out right away. You can start seeing the performance gains right away. So this is one thing really nice to try. So if you don't want to migrate yet, so you can try these 2 things in a POC, run it on Kubernetes or run on a VM that you can that you manage, a test VM or staging. It's good for testing, and then if you see the gains, so you can plan to do the migration. So this is one of the things that we can say that it's serious about this release. Things that makes us adopt Java 25. And what's fun? So I left the fun part to the end, because these are the interesting things that just joined Java 25 that will make our lives easier, actually, as a developer. And one of them is flexible constructors. So we know that creating constructors requires, if you are calling a parent class using super, or calling the class itself using this should be the first statement on your constructor. But now, with Java 25, you can call super or this at any time in your constructor. So it allows you to validate, for example, fields before you call super or before you call this. So this is really interesting. So, for example, this one I can create a simple validation test to make sure that name is not null or blank, and then we can call super, and then we can assign the value. So we can do it like now safer. This is a really nice thing on Java. Another thing, in Java 9, we introduced modules. So Java, you can modularize Java in a way that you can just use what you need. But by that time, you need to use one guy called module info Java for defining the modules. But now, although we still can have module info, now we can import those modules. And the good thing that when we are importing modules, so you can define like the imports, exports, and transitive dependencies, and your import module will respect that. So this can guarantee that you will only import what really means, what really needs. So we used to have like a list of imports. Now we can just use, for example, import module Java base, and we can have like basically the same thing without importing all the things. And I would say the most interesting thing, especially for us, which are starting and then want to write scripts or want to write quick files, quick single apps. Compact source files now allows you to create void main, to create a main method without boilerplate the entire class, without encapsulating in a class, which can make our life more or less the same what we do on structural programming. But the good thing is like now, especially for beginners, they can start learning Java and can start using Java right away without understanding the deep knowledge of object-oriented programming. So you can introduce first the language, and then you can introduce in the object programming after that. So it allows us to learn much faster. And this is what it likes. So we can definitely define constants. We can define global variables, and then we can use it in a void main. We can even define methods outside. And the good thing is that I don't even need to compile this file. I can name this file anything I want, .java, and then run Java and the name of the file. This will run without need using Java-C for compiling. We can run these simple files without compiling. It will get interpreted directly by the JVM. This is another cool thing. I know that I have a short time. I'm almost on that. And one last thing is like scoped values. I put this one in the fun part because actually this one is not actually useful right now, but it will be used when we introduce structure concurrencies, because this guy allows us to create data, immutable data that is shared between threads. And you can guarantee that if you use these guys, so your thing won't get overridden. This is one thing that we had in the past. Remember when you use thread locals? So the problem is that this guy is not immutable. So if we keep setting values by mistake here, this guy gets replaced, and then we lose the file. We lose the value here. Now, it keeps the state for each of our scope. So in the outer scope, so we have admin user, it will print admin. In the inner scope, it will be guest, it will print guest. If it goes back to the outer scope, it will print admin again, because it keeps the values among the scopes. And we have another features, the future features that are coming in probably the future releases. This one I forgot to translate it as well. But the most important one, stable values, which copes with scoped values for immutable values for a predictive concurrency. We have the structure concurrency if we want to break down tasks, and then we can control tasks in parallel when running concurrently. Primitives in pattern matching. Nowadays, it only supports classes starting probably in Java 26 or 27, we can use primitive directly in pattern matching. And the vector API is the high performance vector computation for parallel workloads, really good for AI. And as I mentioned, the GFR for CPU timing. We got this version for method and this for CPU. And that's what we get for the future. Okay. So I don't have much time. So this is the complete blog post if you want to go there and see all the features. I have the examples that you can run. Pretty simple and easy. So thank you for coming. Here is my link tree, so you can get my email, my LinkedIn, my Twitter, and whenever you want to contact me. We have time for one question, actually. So yeah.
So is JFrog like Datadog? I use Datadog to monitor my application. I didn't.
If you use GFR, we get a little bit more information, actually. So Datadog has an agent which runs alongside the JVM, and it gets a lot of information for you. If you enable GFR altogether with Datadog, you start getting a little bit more detailed information. So we start getting information like, as I mentioned, the CPU and the method, memory, and CPU usage, which you already get from Datadog, but you can get like the stack trace. This is one of the important things that we get from GFR that we don't get using Datadog, which is like you can see the trace of all your method calling. So you can see the hierarchy of the methods being called at a given point of time. So this is something that is really good. And now that we are also adding CPU as a preview. Also, you will get more information about the CPU itself. Nowadays, I think Datadog is able to get like information, like some information about the garbage collector and the CPU usage, but you don't have actually the CPU timing that your threads are consuming. And that's one information that we'll get probably in the next JVM, that you can get like the exact amount of time that your thread are spending on using the CPU itself. Okay. So, hey guys, so thank you very much. I'll be around if you wanna discuss. Thank you.